So here we are. We have the Neanderthals territory. Now we know the Neanderthal is expanding farther to the east. But here in Israel is actually the border of their distribution. And Homo sapiens in Africa, this is the border of distribution for him. And because the glaciers and the very harsh conditions that come with the glaciers are actually shifting, okay? We see in the caves of Israel, we see that the caves are actually sampling sometimes the Neanderthal. When the glaciers are retreating, Homo sapiens is being sampled in the cave. And it goes back and forth several times. So the big mess that puzzled so many generations of researchers about what's going on here in the Middle East, especially in Israel, stems, in my opinion, just from the fact that this was the borderline, and the borderline was shifting. I'm talking about, let's say, 25,000 years, shifting quite a lot from Africa to Europe, and from Europe back to Africa. So this is about what I have to say. Okay.
Horses and donkeys.
I'm sorry?
Horses and donkeys can breed into a mule.
Oh, yeah. You're talking about breeding.
Is there evidence for interbreeding?
Well, now that we have the genome, first of all, we have to define. It's not an easy task. And I, 5 years in Berkeley, there was not a single week that went by without a discussion about the definition of a species. What is a species? And it's not settled. The most common criteria is if they exchange genes willingly, okay, and they produce fertile offsprings. So horse and a donkey, they produce a mule that is actually sterile. We are talking about two species. Now, since we do have the genome, there is recently, it's not in the mitochondrial DNA, but in the real nuclear DNA, we see that there is a trace, very, very little of Neanderthal DNA that went from a male to a female Homo sapiens and not the other way around. Very dramatic, okay? And so some people say maybe they had gene exchange. They didn't have gene exchange. They had one direction gene flow from Neanderthal men to the Neanderthal woman. I'm sorry, to Homo sapiens woman. And this is why in the mitochondrial DNA, you don't find, in Neanderthal, you don't find traces of Homo sapiens DNA. The difference between them anatomically is so great that if you take the yardstick, okay, of what is known today to define a species in a living world, there is no doubt that we are talking about two different species, okay, because of the magnitude of the anatomical differences. Still, I have to say that they are very close species, okay, very close species. And you have to remember that among 10% of legitimate species living today, there is some kind of a gene exchange. So this is what I have to say about. Now I was saying, I'll just add one more thing, because I was saying that the common ancestor lived 600,000 years ago. We know from the DNA of Homo sapiens that the origin of Homo sapiens is about 150, maybe 200,000 years ago. Okay, this is the origin of the species Homo sapiens. In other words, in order to bring the two branches together, we are missing some players. And maybe the very small quantity of Neanderthal DNA is going through this chain, okay? And Neanderthal and Homo sapiens didn't interbreed, okay?
And we found that this individual shared a common origin for his DNA sequences with Neanderthals around 640,000 years ago. And further back, 800,000 years ago, is there a common origin with present-day humans. So this individual comes from a population that shares an origin with Neanderthals, but far back, and then have a long independent history. We call this group of humans that we then describe for the first time from this tiny, tiny little piece of bone for Denisovans after this place where they were first described. So we can then ask for Denisovans the same things as for the Neanderthals. Did they mix with ancestors of any of the present-day people? If we ask that question and compare the Denisovan genome to people around the world, we surprisingly find no evidence of Denisovan DNA in any people living even close to Siberia today. But we do find it in Papua New Guinea and in other islands in Melanesia and the Pacific. So this presumably means that these Denisovans have been more widespread in the past, since we don't think that the ancestors of Melanesians were ever in Siberia. So from studying these genomes of extinct humans, we're beginning to arrive at a picture of what the world looked like when modern humans started coming out of Africa. In the West, there were Neanderthals. In the East, there were Denisovans, maybe other forms of humans too that we have not yet described. We don't know quite where the border between these people were, but we know that in southern Siberia, there were both Neanderthals and Denisovans, at least at some times in the past. Then modern humans emerged somewhere in Africa, come out of Africa, presumably in the Middle East. They meet Neanderthals, mix with them, continue to spread over the world, and somewhere in Southeast Asia, they meet Denisovans, mix with them, and continue on out into the Pacific. And then these earlier forms of humans disappear, but they live on a little bit today in some of us, in that people outside Africa have 2.5% of their DNA from Neanderthals, and people in Melanesia actually have an additional 5% approximately from the Denisovans. Does this then mean that there is, after all, some absolute difference between people outside Africa and inside Africa, in that people outside Africa have this old component in their genome from these extinct forms of humans, whereas Africans do not? Well, I don't think that is the case. Presumably modern humans emerged somewhere in Africa. They spread across Africa also, of course, and there were older, earlier forms of humans there. And since we mixed elsewhere, I'm pretty sure that one day, when we will perhaps have a genome of also these earlier forms in Africa, we will find that they have also mixed with early modern humans in Africa.